Hi everyone, today we are going to discuss yet another element of the logical design, that is the logical database design. So this is another element while designing the logical design, that is the logical database. Now when I say logical database, that means something that is not physical, something that is not existence but in conceptual terms. So logical database is basically nothing but a conceptual database. So conceptually we are designing the database before the actual physical database is designed. So this is what logical database design means. So basically data modeling is used for logical database design. Whenever we have to design the database logically, that means for the logical database design, the data modeling is used. So a conceptual model of data is used in an application which is obtained by using an entity relationship model or an ER model. So as I told you, logical database design means designing the database logically or conceptually. So how do we get the conceptual data model? By using entity relationship models. We use the ER models or the entity relationship models for designing the database conceptually, and this ER model is your data modeling tool, which I told you is used for logical database design. So basically an ER model is used for the conceptual modeling of the database or for the logical design of the database. Now, ER models assist in designing relational databases. What kind of databases can be designed using the ER model? The relational databases. Relational database consists of a collection of relations which are relevant for a specified application. Now, when I say that ER models are used for designing relational databases, then you must be thinking what relational databases are. So, relational databases basically are those databases which consist of collection of relations. And what are these relations? In a layman's language, these relations are known as tables. So, one table represents one entity set. So basically relations are representing the entity sets, and these relations representing the entity sets are relevant for a specific application. Obviously the relations will be relevant to this application for which the software is being made. For example, if you are making a software application for an institute, educational institute, then while designing the logical database of that institute, you will have relations relevant to that institute, like relations for student entity set, relation for faculty entity set. So when I say relevant for a specific application, that means specific to that application and not outside that application. A relation, as I told you, is a table which depicts an entity set. Relations in layman languages are known as tables, and these tables are representing individual entity sets relevant to a particular application. Now, since relations are tables, that means they are represented in tabular form, therefore it is quite obvious that they will be having columns as well as rows. So now let's see what does the column of a relation represent and what does the row of a relation represent. Each column in the relation corresponds to an attribute of the entity. So whichever relation you take, each column of that specific relation corresponds to what? Attribute of the entity. That means each column of a relation is representing some or other attribute of an entity set. So for example, student ID, there will be a column for student ID which will be having all the student IDs of all the entities belonging to that particular entity set. Similarly, student name, student course, these are all attributes, and every attribute is represented in a column. That column will have the similar kind of attribute. Then each row contains a member of the entity set. Just like columns represent attributes, rows represent the members of the entity sets. Meaning every row is representing one entity from the entire entity set, and that means I can say that each row is representing a record of the entity set. For example, if you have a student entity set, then one individual student in that student entity set is represented by the row. Now, while conceptual database design or logical database design, normalization is also used. What is normalization? It is a procedure which is used to transform a set of relations into another set which has some desirable properties. So basically, why is normalization used? When initially we design the relations, they are in their raw form. So later, with the passage of time, we discover that there are some flaws or anomalies in those relations which have to be corrected or filtered. So for that reason, normalization is used so that the relations in their original or raw form can be transformed into the relations which have all the desired or desirable properties required in a relation. So for that reason, we use normalization. Normalization basically ensures that the data in the database are not unnecessarily duplicated. Basically, there are so many relations in the database, and one or more of the records or attributes may be repeated in several relations. So we have to make sure that when more than one copy of a record or an attribute is used in several relations, there is no unnecessary duplication. So normalization also helps in controlling unnecessary duplication of data in the database. It also ensures that addition and deletion of entities. Obviously, there are times when we need to add data into the database, or when we need to delete the data from the database. Say for example, in the student entity set, when a new student takes admission, you will add the records for that particular student. Similarly, when an old or existing student leaves the institution, you will delete the records for that particular student. So with the passage of time, we may need to add or delete records from a database. So with the help of normalization, we can also ensure that whenever there is an addition or deletion of rows from the entity set or from the relation, or when there is a change in an individual attribute. Individual attributes, say for example, there is a student address. Now the student changes his address, so the address attribute will also be changed accordingly, right? So that means if there is a change in any individual attribute value, or when there is an addition or deletion of rows from the entity set, this does not lead to accidental loss of data or does not lead to any errors in the database. Accidentally, the data should not be lost while you are adding or deleting the rows in the database, or while you are changing the attribute values. Similarly, there should be any error in the database while adding or deleting or the records in the database, or changing an individual attribute from the database. Say for example, you have added the record in one place and it is not added to some other place where it was required, or you've deleted a record from one place but it has not been deleted from the other place, or for example, you changed the student address attribute in one of the relation where it existed, but you did not change it in the another relation where the same attribute existed. So any such kind of errors do not creep. For that reason also, normalization is used. So this was all about the logical or conceptual design of the database.